step 7, describing segments. We now want to look at how can we include several descriptor variables in a model, and we are using the regression framework for this, where we have a dependent variable and we have explanatory variables, and explanatory variables will be our descriptor variables, and the dependent will be either being a member of one specific segment or being the segment membership vector itself. What we want to look at first is how does R treat categorical variables as explanatory variables, and we'll look at this using linear regression. Linear regression in R is implemented in function lm. We have here as dependent variable h, and we want to have it explained by the segment membership. And the -1 means we don't want to have an intercept included. So let's have a look what the fitted model looks like in this case. This returns an object of class lm, which the print method tells us how was the object created, and then we see the vector of regression coefficients, and they are in fact identical to the mean values of h. So what does R do for a categorical variable? This categorical variable has 6 categories, so it creates a dummy variable for each category, which is either 0 or 1, and it takes a 1 if an observation has this category and is 0 otherwise. So this gives us this result. If we want to include now an intercept in the model, the problem is we can't fit an intercept and all 6 regression coefficients for the categories, because that would be over parameterized, and what R does, it selects the first category as the baseline category and merges this sort of with the intercept. So we see the intercept here is now identical to the regression coefficient for the first group, and all other regression coefficients now model the difference between that segment and the first segment. So we see on average respondents in segment 6 are 5 years older than those in segment 1. And the predicted value for segment 6 is obtained using intercept plus the difference. Now let's have a look if the dependent variable is segment membership, telling us is a person in segment 3 yes or no. So this is what we want to use as a dependent variable, and we want to have it explained by 2 descriptor variables, a metric one age and a categorical one obligation. So that's the model we are specifying using that formula. Now we want to fit that model, and we need to do this using the generalized linear regression framework, GLM, and that's implemented in that function of the same name in R. So we specify the formula and which data should be used to evaluate the formula, and then in addition, in contrast to the LM function, GLM has a family argument. In the family argument, we specify what distribution are we assuming for the dependent variable and how are we linking the mean of that distribution to the linear predictor. So in this case, we have binary data, we assume binomial distribution, and the binomial distribution has as mean parameter the success probability, which can only take values in the interval 0 to 1. And we are using, by default, the logit link to transform this success probability to a variable which is in the interval of -infinity to +infinity, and that's which is then modeled using the linear function. So we're fitting that model, and if we look at the model output, that's now an object of class GLM. That's the call. And here we have the regression coefficients. They tell us how does the linear predictor change, and we need to transform this using the inverse logit function, the inverse link function, to obtain the predicted probabilities of being in segment 3. So these coefficients do not tell us how does the predicted probability change, but how do log odds change. To ease interpretation, we can look at the visualization of the effects using a function available in package effects. And if we want to just look at all effects we've estimated, we can use the function all effects and plot the returned object with our fitted model. So we have 2 covariates in our model, so we get 2 plots, and this gives us how does the probability of being in segment 3 changes if a person gets older. We need to keep in mind that the effect of age changes depending on if someone has obligation value 1, 2, 3, or 4. So this tries to give us an impression what's the average age effect. So for a person with an average obligation score value, analogously, this will tell us how does the probability of being in segment 3 changes for an average aged person if we change its obligation value. The gray area here are 95% pointwise confidence intervals. So this tells us how unsure are we in estimating that effect, and more or less if a straight line fits in through here, this would be an indication that age doesn't have a significant effect. Here also we have 95% confidence intervals, and we see the higher the moral obligation value, the lower is the probability of being in segment 3. To formally test an effect, we can use either summary. So for example, here line H that tests the null hypothesis of this regression coefficient being 0, where all other variables are still included, versus that it is unequal to 0. And here the null hypothesis is retained, so we cannot reject the null hypothesis that the regression coefficient equals 0, so we would conclude age doesn't have a significant effect. And these tests also give test only that one specific level of that explanatory variable has the value 0. This might not be too insightful, and we'd be interested in testing are all of these regression coefficients equal to 0? So what happens if we leave that variable out? And we can do this using function ANOVA from the package car, which performs a likelihood ratio test for given the model. We're comparing the full model to the model without age. Does this lead to a significant decrease in goodness of fit? Where the answer is no. And we get essentially the same test as here. Or here we're testing the full model versus the model without the variable obligation 2, and we see this leads to a significant decrease in goodness of fit. So we'll conclude that obligation has a significant effect on the probability of being in segment 3.